Thank you, Anat. And so I'm going to give a few opening remarks before we start the session. But in the meantime, I'd like to call Professor Detlef Stolten to come up, the chairman of the executive committee for the IEA, Advanced Fuel Cells Agreement, and Dr. Piotr Zelenej from Los Alamos National Lab, who is the head of the new consortium that we launched called ElectroCat, Platinum Group Metal-Free Catalysts, and then Dr. Lior Elbaz, who is the head of the Israeli Fuel Cell Consortium at Bar Ilan University. And so what I'll do first is give you a few opening remarks for those who are not too familiar with the fuel cell and hydrogen industry. And maybe I'll ask first, how many of you have been involved with hydrogen and fuel cells for 5 or more years? If you can raise your hands. Okay, so there are quite a few that are maybe not that familiar with fuel cells. So I think for the fuel cell industry, this is actually a very exciting time. We have, every year, DOE publishes a market report, and our recent one was just published, and we show over 60,000 fuel cells that were shipped worldwide. So becoming a commercially viable industry. Most of them, actually, you can see in the green, were shipped in Japan. And these are small stationary units. Major companies, Panasonic, Toshiba, since Fukushima, we're seeing greater interest in fuel cells, small residential fuel cells that run on natural gas, provide power and hot water. And then, of course, we see huge market potential, various projections across sectors again. And then, of course, I think the major announcement is, for the first time in history, commercial fuel cell vehicles on the road running on hydrogen for sale or lease. And we have, within DOE, this session is really focused on fuel cell technology roadmaps, and we'll hear from some of the different stakeholders up here on what their plans are. And so to give you some idea of the DOE program, we spend about $100 million a year in my office, again, focused mostly on R&D, but the mission is to enable widespread commercialization. We know that fuel cells are commercial in various applications, but how do we get widespread commercialization? We spend a lot of effort developing technical targets, both in terms of cost and performance. And these are really market-driven, so we get input from companies, from industry, and some of this information is company-sensitive, so we share really the DOE targets that have been vetted, and we have a number of targets, so cost, for instance, durability, hydrogen storage, hydrogen, and that's what's needed to be commercially viable. And as I mentioned earlier, part of our strategy and our roadmap is it's going to take time to get the vehicles out, and so we look at how do we bring the cost down through early market applications. We talked about the forklifts, we heard about buses, we have the world's first fleet of ground support equipment, baggage tow tractors at airports, we mentioned backup power. So how do we really, this is a completely new technology in many ways. So if we're looking at mass market penetration, again, the goal is getting our carbon emissions down. We need to get volume. So we're looking at a number of different opportunities. And so this session is going to focus a little bit more on the R&D. So we started with Anat at kind of the high level, and we want to see what more needs to be done. So again, to set the stage, most of our effort has been R&D, and you can see over the years, especially for those not familiar with fuel cells, we've reduced the cost 50% since 2007, 5 times less platinum loading, number of demonstrations, over 6 million miles of driving, again, the early vehicles, and then I already mentioned the deployments and how we're using government funding to enable market penetration, again, ramping down government funding where appropriate. We have in the US H2USA, which is a public-private collaboration focused on infrastructure, and then we have a number of R&D areas, and Piotr Zelenej, as I mentioned, is leading the ElectroCat here. So finally, I'd like to just touch on where we are in the technology compared to where we need to be. So again, there's been lots of progress, but we need to focus on still reducing cost. So we have our various targets for 2020, and then we every year assess the projected cost at high volume based on state-of-the-art technology. And then, of course, at low volume, the cost is still high. So again, for those in the R&D community, we still need to reduce cost. And all of this information is available on our website. And it's not just about cost. We need to address all of our targets. Durability and cost are really the main ones that need to be addressed. I mentioned, finally, h2tools.org. For those that are interested, again, to get information, you can see lots of international access. How do we provide information is also important. And then finally, I think the last point I'll mention, and I think Detlef will talk a little bit more about this, is when we talk about hydrogen and the transportation sector, it's important to realize that if we're going to get our emissions targets met by 2050, we're really looking across sectors. And so when we look at the mass market penetration now of renewables, we're seeing the need for energy storage. So you can go from electrons to electrons with battery storage, but the other option is to produce hydrogen as an energy carrier. You can inject that into the natural gas pipeline. You can use it for transportation fuels, synthetic liquid fuels, upgrading biomass, and then the whole industrial sector, which is a huge greenhouse gas emitter. Just steel production alone it represents more than 8% of global greenhouse gas emissions. So you can look at fertilizer production, a number of different applications that use hydrogen. So getting green, low-carbon hydrogen is another approach. So I think it's important to look at cross-sector advantages of hydrogen. So finally, before we go on to the panel discussion, I'll end with a quote by an American Nobel Prize winner. The hardest problems of pure and applied science can only be solved by the open collaboration of the worldwide scientific community. So again, I think it's a testament to the great work, the researchers that we have here today and over the years. We need to ramp up efforts. You know, we're really close. For the first time, again, commercial vehicles, but we're not there yet. And I think it's really important to look at what the additional issues are. So.